Okay, good evening. Let me start with the another example for mechatronics system. Already we saw washing machine, camera, and robot. Now we will see about the fuel injection system for petrol engine. This slide shows that the basic working of a four-stroke petrol engine. Left side, this is a four-stroke engine. We all know that you have the cylinder inside which there's a combustion chamber. Correct? Combustion chamber is there. In the combustion chamber, uh, and let me start with right hand figure that may be easy to for you to understand also. This is a single cylinder engine, correct? In which this is the cylinder, and you have the piston, and piston is moving up and down. This is your connecting rod connected to crankshaft. Okay, this area is called combustion chamber. Okay, then what you have is you have this is called as inlet port, and this is called as exhaust port. I can call this EP and IP. Sorry, small this one. Let me, yeah. So this is the atmosphere, and this is the inlet port. This is exhaust port. When piston goes down during the suction stroke, a vacuum is created in this area. Then the inlet valve is opened by the camshaft. This is the camshaft driven by crankshaft through belt mechanism, timing belt. You can see that the inlet valve will open. So when the piston goes down, a vacuum is created. So the air, which is shown in blue color arrow from the circle from the atmosphere, this is the air filter, removes any dust. Then this is your throttle plate. Right? This is the throttle plate, and which is controlled by the driver. This is controlled by driver. When you valve opens, okay. So please note that this is called inlet manifold, a long pipe. Please know that here it's shown a straight pipe, but actually the pipe is little twisted, so that the air which is coming inside the combustion chamber goes and swirls. Right? Swirling action happens. So the actual manifold pipe is not a straight pipe. It will be twisted moment. Air will enter and swirl inside the combustion chamber. So the fuel air mixture will mix and a homogeneous mixture is created. So the designing the inlet valve itself is again a special art, and that we will be doing separate, but we are not here to know that. So when piston goes down, vacuum is created since inlet port. This is inlet port, and this is called inlet valve IV. Please note that this valve, inlet valve and out exhaust valve, both are spring operated. Normally they will be closed. During compression and power stroke, they will be closed. During the suction stroke, inlet valve is open, outlet valve is closed. So the air from outside is coming in. When it comes in, fuel will be sprayed through the injector. This is a fuel injector. The fuel injector is controlled by ECU. ECU is here. You can see that this is connected. This is the signal coming from this one, and the ECU will give a square pulse. Generally it will be a 12-volt pulse will be supplied to the injector, and this is called as injection duration. Injection duration. That will be varied depending upon how much torque you want. When you press the accelerator more, the injection pulse duration will increase like this, right? So when you want less, this is for example 1 millisecond, and if I for 20% throttle open, if I do, then it become more. So like that the pulse width will vary. So that is called pulse width modulation. Okay, the injector opening duration varied depending upon the throttle position, because we know that throttle can vary from 0% to 10%. When 10% throttle is there, the throttle valve will be fully open. This valve will be fully open. The air will be go without any restriction inside the combustion chamber. So that means more air can go in. Okay. So we know that so this is our structure, the fuel injection system. This is called a port fuel injection system. Short form is called PFI. It is called as PFI, short form. And you can see that from the fuel tank, because the fuel will be sucked, and there will be a filter, and it will be pressurized. Correct? There's a filter, and also there's a pump which pressurizes fuel. Here it is 1 bar pressure, but when after the pressurization at this location, the fuel pressure can be something to 3 to 6 bar anywhere. 3 bar, 4 bar, 5 bar, 6 bar. There will be the fuel pressure. Normally in PFI, fuel pressure will be around 3 to 6 bar, around that. It can vary plus or minus, but generally around that only. So the pressurized fuel comes and waits in the injector. Okay. When the injector is open due to pulse width, the fuel will be sprayed in this. Correct? Please note that the fuel is injected at the inlet port. This is inlet port. That's why it got port fuel injection system. We have another type of fuel injection system which is called as gasoline direct GDA engine. GDA engine, the injector will not be placed here. Instead of that, like a diesel engine, so fuel will be injected inside the combustion chamber. So that is called gasoline direct injection system. It is similar to the diesel engine fuel injection system. Right now we are not going to talk about that. We will take an example for you can note down. See that this is the T-pacer attached to throttle plate. We know that when driver presses the throttle pedal, the throttle plate will rotate 0 to 90 degree. Okay. Now I told you this is a pipe. If this is a cross section view, if I see from side view, this is pipe, inside with this is throttle plate. Throttle plate will be like this, and this is throttle plate stem, and it will be like this. This is the inlet manifold, a pipe. If you think like a pipe, this is what the throttle plate. Now the throttle plate is fully closed. When you start the engine, when it is at neutral gear, you don't press throttle pedal. The throttle plate will completely close so that no air can go in. No air can go in, because this side I have the engine. Correct? This is my engine. Air cannot go out because throttle plate is completely closed. During that time, you can see that there's a small bypass valve is there. This is called air bypass valve. This valve, the air coming out from here will, instead of going, because throttle is completely closing at the zero throttle or idle condition, still engine needs air. The air will go through this valve, this pipe. Correct? The valve will open. This is called bypass valve, idle bypass valve, also called idle bypass valve. This valve will be open, so air can go, because this throttle is closed. Air will go through this and go into combustion chamber. So small quantity of air is sufficient that air, again fuel will be injected so that engine can run at idle condition. So this is the bypass valve is meant for controlling air during the idle condition. But once you press the throttle will start opening 0 degree, 2 degree, 3 degree, depending on what the driver presses. As driver presses, the throttle will open, more air will go. That time this valve will be closed. Once throttle is pressed, the bypass will be closed by ECU. This is, please see, the ECU is going to control the bypass valve. When throttle is pressed, the throttle angle, TPS sensor measure the current throttle angle. When throttle angle theta, I said that the theta T is greater than 0°, bypass will be closed. So the air will directly go inside. If it is the throttle is not pass, engine should run. During that, this valve is closed. So the bypass valve open, air will go. This is how it works. So in fuel injection system, already we know that it is a mechatronic system. Engine is a mechanical system. It has correct. It has fuel injector and it has lot of sensor, TPS sensor. Then bypass valve. This also again it is called actuator. This is an actuator. Fuel injector is an actuator, and it has throttle position sensor and also crankshaft position, which is used for measuring engine RPM. Engine RPM will be measured using crankshaft sensor or the engine RPM sensor. Then you have a exhaust oxygen gas sensor. You can see that this is called EGO, exhaust gas oxygen sensor, or simply oxygen sensor. Sometimes they call lambda sensor also. These are the different name given for this sensor. Okay. So then you have one more important this one, which is called catalytic converter. This is called catalytic converter. In fact, they call three-way catalytic converter. In petrol engine, it is called as three-way catalytic converter, TWC, short form. Okay, that is this, which is connected at the end of the tailpipe. So the exhaust, which is coming from engine, will pass through the catalytic converter. This is made of porous ceramic material. Please see the cylindrical. See, outer body is made of stainless steel something, which is part of the cylinder, your exhaust pipe. But inside this one, cylindrical shape, you have porous ceramic material through which the exhaust will go. Porous means you have micrometer diameter porous structure, porous ceramic structure through which the exhaust can go. When it passing through that, the porous ceramic structure will be coated with platinum and rhodium. Okay, platinum and rhodium. One is called as oxidation catalyst, other one is called reduction catalyst.
Sir, this is why they tend to get stolen, no, sir?
Yeah, because they will remove because it has the platinum and rhodium, because very expensive, it is costlier than gold. Correct? 1 gram of platinum is sometimes costlier than gold. Or rhodium, they are called rare earth metal. They act as a catalyst. They act as a catalyst which will convert HC, CONOx into CO2 and H2O. Because we know these are the toxic gases which should not come out of your tailpipe. This should be removed. So what the catalytic converter will do is it will convert these three gases into CO2, H2O. Right? So that is the job of three-way catalytic converter in tailpipe. Okay. Now, if I want to use these are things that how it works, I will quickly explain. We know that this is a four-stroke engine. This is called a suction stroke. Piston is initially piston was here, which is called a TDC. From TDC during suction stroke, piston is moving down. It comes to BDC. This is BDC. When piston moves from this is called stroke length SL, and piston moves from top position to bottom BDC. There's a vacuum is created. This is the vacuum. So the inlet, if inlet valve is open, the air will come inside. That time you will inject the fuel also in the inlet port. So the fuel mixes with the air, and the fuel air mixture is formed inside the combustion chamber. Correct? So this is called suction stroke. Once piston comes down to BDC, by the time the crankshaft is rotated 180 degree. From 0 degree it is rotated 180 degree. That time the piston has come from TDC to BDC, so vacuum is created. Air and fuel mixture come inside the combustion chamber. During the time, you can see that only inlet valve is open. This inlet valve is open, exhaust valve is closed. At the end of this one, inlet valve closes, already exhaust valve also closed. Then piston moves from BDC to TDC. This is the TDC. It is moving upward. This is called a compression stroke. First one is called a suction stroke. Correct? This is called suction stroke, during which air and fuel is sucked inside the combustion chamber. That time inlet valve is open and the exhaust valve is closed. During compression stroke, inlet valve also closes. The air fuel mixture is compressed because from DD this one. So generally, the petrol in SA engine we call a compression ratio. Compression ratio in petrol engine will be generally 8:1 to maybe 12:1. Generally, it can anywhere 10:1, 9:1, 11:1, somewhere between these ratios. They call compression ratio, right? So if I say 10:1, if we say 100 cc engine, air will be sucked in 100 cc when this position, this volume is 100 cc. 100 cc. For example, most of the 100 cc motorcycle in India we can sell more, correct? TVS, everybody is selling 100 cc. From when the piston is at BDC, the combustion volume inside the combustion chamber is 100 cc because single cylinder is 100 cc. Now, if I say 10:1, it will be compressed to 10 cc. 100 cc will compress to 10 cc. And now, when piston is go, they call compression stroke. Before the piston reaches TDC, a spark will be given because in petrol engine you have to give a spark. So the spark plug is there. You can, this is spark plug. Spark is given. When spark is given, the fuel air mixture start burning. Correct? We call it combustion. Once combustion happen, due to combustion, the temperature inside the gases, correct, hot gases are produced. Because fuel air mixture burns and produces CO2 plus H2O. Basically, what you are giving is Hc plus O2. Hc is nothing but your fuel. O2 is the oxygen in the air. Now, these two will combine, will form CO2 and H2O in case of perfect combustion. Many times, to make a perfect combustion, you need to have particular temperature, particular pressure, and fuel air should be mixed properly, what you call homogeneous mixture. All the conditions should be created at the end of the compression stroke, but doesn't happen every cycle. Due to that, you will get CO plus Hc plus NOx. These three are called as toxic gases, which is produced in engine, which we want to, because we don't want to happen, but it happens because we cannot create perfect combustion every time. Because sucked air will not be pure, it may have some moisture, fuel will not be a petrol, it can be adulteration will be there, and there are many parameters which decide the combustion process. Due to that, CO, H, unwanted, these are called unwanted, along with CO2 and H2O. The whole idea is, I already told you, the three-way catalytic converter is used to convert this CO, Hc, NOx into, again, CO2 plus H2O. H2O is water, it will get a steam. So the toxic gas also will be converted. That is the job of three-way converter, which is fit on the exhaust pipe. Okay. So now, once you give that fuel air burner, the temperature increases, so the pressure increases. You know, PV equal to nRT, the ideal air gas. The air is compressed 10 times, so the pressure is already high. Due to that, already temperature, air itself increased. Now you given a spark, fuel burns, so that means the temperature you start increasing around 800 to 1000 degree, correct? So N and R are constant, correct? N and R are constant. Automatically, if temperature increases, the pressure also. Temperature increases, pressure also increases. So there's a downward force is created. Force is created by hot gases because high pressure. So that force pushes the piston down. This we call a power stroke. So from TDC, the piston will come up to BDC. That time the power stroke ends. During this stroke only, engine generates power, torque, all those things. Once it comes this one, then again piston start moving because a crank mechanism. Automatically from BDC, the piston will start moving towards the TDC. Correct? During that time, you see that the exhaust valve is open, inlet valve is closed. So the exhaust gas goes out. Correct? Exhaust gas goes out by the exhaust pipe. So this is how the SA engine is working. Correct? The SA engine works. So to now, the whole idea of the ECU or embedded controller is to control when to give the fuel or inject fuel, and when to give the spark. Correct? We know that fuel should be injected in the suction stroke. During suction stroke only, fuel, during that time only, the injector should be opened, so the fuel is sprayed in the inlet port. Once the suction stroke is over, the fuel injection should be stopped. You should not inject. So inject will be automatically stopped. Injector will not get 12 volt pulse. Then during the end of the compression stroke, few degree before TDC, you give spark. You give the spark, automatically the fuel air start burning during the power stroke. Okay, actually start burning from the suction of the compression stroke itself. We know that it is called as spark timing. It is called as spark timing. Spark will be given not when the piston, correct. For example, this is TDC position. Moving from BDC to TDC, that is what maximum position. When piston is somewhere hits up, correct, you will give a spark. That is called as spark advancing. When piston reaches TDC, that is the theta is called as 0 degree. Correct. If I give a spark 10 degree before TDC, theta will be 10 degree. I can give 20 degree before. Correct. The spark will be, when you are giving spark or spark advancing, depends upon engine speed. Engine speed decides the spark timing. Okay, decide the spark timing, the theta. Now I will show in this one. I have the spark timing back. I will show you, then you will understand. So basically, this is how the engine works. Okay. So now whole idea is we wanted to control the engine. Okay. So what are sensors used in SI engine control? Correct. Fuel injection system control. I have an electronic ECU, which consists of microcontroller. It has a memory where I store a program, and also it has AD converter. AD is called analog to digital converter. This IC is used for converting analog sensor signal to digital signal, so that it can be given to microcontroller. The whole thing we call ECU, or electronic control unit, which is like a small computer. We know that computer can understand only binary numbers, binary signal. That is the job of the ADC. We will see how the ADC working as a part of this course. I am going to talk about what ADC, how it works also we are going to see. Right now you understand that the signal coming from sensor is analog signal. Analog signal means x-axis we always represent in terms of time. Time is 0 second, it goes to infinity. Y-axis is nothing but signal strength. Signal strength is always measured in terms of millivolts or microvolts many times. Most of the sensor. So now, if I say the pressure sensor, if pressure is varying to 0 to 10 bar, the pressure sensor will give a signal like this. Right? So this is the signal coming from pressure sensor. It is in millivolts varying. Since the signal is varying with respect to time, it is called as analog signal or continuous signal. Analog or continuous signal. It is called as continuous. Most of the sensor gives with analog signal only. This signal, which is in millivolts, should be amplified. The signal cannot be given directly to microcontroller. It should be amplified. So you will have electronic amplifier circuit. We are going to see about that amplifier circuit, and also ADC. Correct? From millivolts, the signal will be amplified to volts. Not in hundreds of volts. It will generally few volts, up to 5 volts. Then it will be converted into binary signal. Binary signal means it will consist of zeros and 1 0 1 0 1 0 something. This is called binary number. So it also represents 0 volts or 5 volts. They call it digital signal. This signal only microcontroller understand. So the job of the ADC is that. Okay. So you have a microcontroller or embedded controller, a ECU we call it. Apart from for that, ECU receives signal from various sensors. Important sensors are, these can say that exhaust oxygen sensor, oxygen gas sensor, The short form is the EGO sensor, which measures the amount of oxygen coming into tailpipe, which is indication of air-fuel ratio of the engine. Then IAT means inlet air temperature sensor. Inlet air temperature sensor. TPS is throttle position sensor. MAP sensor is manifold absolute pressure sensor. KS means knock sensor. And cam position sensor. Okay, you can see that the ECU in a typical engine may have few of the sensors, will not have all the sensors. Depending upon cost, all those things, what performance you need in the fuel injection system, you will have few sensors, not all. Okay, and but these are the important sensors most widely used. Now, based on the signal, the microcontroller generates fuel injection pulse, PWM pulse, which is called as pulse width modulation. PWM signal is the output from the microcontroller given to the fuel injector. This is going to open because this is always 0 to 12 volt pulses. The duration of the pulse going to decide fuel quantity. The inject will be open. For example, generally the duration will be in the order of milliseconds. Maybe 1 millisecond to 5 milliseconds. Okay, and already told the fuel injector, the fuel is connected here. Right? The high pressure fuel is connected here. To high pressure fuel. Told you the pressure will be 3 to 5 bar. So for this duration, for example, if injector open for 1 millisecond, injector, there's a small nozzle, maybe micrometer, say 100 micro, 50 micro something. Injector open for this one, fuel will be sprayed for 1 millisecond. That quantity may be 1 milligram. For example, I am saying, depending upon the fuel pressure and the nozzle opening size and the duration, the fuel quantity is controlled. If I want 2 milligram fuel, what I will do? My EC will open the injector for 2 milliseconds to more time. So then 2 milligram fuel will be injected. By varying the pulse duration, which is called the pulse width modulation, wherein the ECU controls the fuel injected, so the torque produced by engine, so engine load carrying capacity and speed varies. That's how it works. Okay, then in SI engine, please note that the torque produce is proportional to air-fuel ratio and spark timing. We call in the theta, correct? That is so many degrees before TDC and air-fuel ratio. These two parameters going to decide. So that means if you want to control the torque produced by engine, you can control using air-fuel ratio and also spark when you are giving spark before TDC. Apart from that, many latest generation engine, you have a radiator, correct? And the radiator has a fan, cooling fan. Many times, old generation car, it is driven by belt drive. Engine cooling, radiator fan will be driven by engine. Nowadays, we are using electric motor, electric fan to cool the radiator. That also will be controlled by ECU. And also, you have this inlet air control, correct? Inlet air control. This is the bypass valve, air bypass. This which I talked here, IAC, ideal air control. This valve also is another this one. These four are called as actuators, correct? Generally, most of the engine, modern car engine will have fuel injector, electronic fuel injector, spark timing control using electronic control, and electric fan controlling the radiator engine temperature, coolant temperature, and ideal air control during the controlling bypass valve, this valve. So you have 4 actuators, and you may have at least 2 or 3 or 4 sensors. The sensor information goes to ECU. Based on this signal, the ECU is going to control the pulse width modulator, this one, also the spark signal. Spark also given as a 12 volt signal, and which will be amplified in 20,000 volt, 30,000 volt high tension coil, finally given to spark. Correct? So here the spark timing is controlled, here the pulse width is controlled, and the voltage applied to motor, the fan, also will be controlled by a driver. So that cooling fan, whenever wanted switch on, unnecessarily driving a fan is going to waste your energy. Okay. So now if I want to, what is that? We know that air-fuel ratio control is most important in this. What air-fuel ratio is nothing but mass of the air divided by mass of the fuel. Now we know that in petrol engine, air-fuel ratio should be maintained somewhere 8:1 to 22:1, and it may go sometime 24:1 also, slightly higher also in case of GDI engine. In GDI engine, it can go up to 28:1 also, 20 more than 24 to 28 in case of GDI. In PFI, in the port fuel injection system, the air fuel ratio will be maintained only in this. Generally, this is very rare. Most of the time, it can be 10:1, 9:1 to 20:1. So air fuel ratio has to be maintained. So now, how the controller works here is it measures the so to control air fuel ratio, what is important, that means amount of mass of the air. Please note that during the suction stroke, I told you during the suction stroke, air is sucked in. Right? The quantity of air is controlled by TPS sensor. Correct? The throttle position, that is controlled by this valve, throttle valve. That position is measured by the sensor. Sensor only measures the angle. Okay. We always mention as alpha. Throttle angle measurement is alpha. One that is known, you can always find out amount of air vented using throttle equation. There's an equation called throttle equation, which says that if throttle is open, I told you throttle angle can vary from 0 degree to 90 degree. This is 10% throttle condition. This one, this is 0% throttle condition. So throttle valve, this valve will vary 0 to 90 degree. And if you know that if you measure this alpha, the theta, alpha throttle angle, the ECU can compute what is the amount of the air venting. Apart from that, now what I want to say is here we are, if I through the throttle angle, I can find volume of the air venting. Correct? Volume of the air venting, air sucked by the engine. But I told you here our interest is mass of the air divided by mass of the fuel. Air fuel ratio never we talk in terms of volume basis. Mass of the air sucked inside the combustion chamber during the suction stroke divided by mass of the fuel you are injecting, this is the air fuel ratio. That means you need to find out the mass. So now the ECU can compute once volume is known. How the volume is computed using the TPS signal. TPS sensor gives alpha, that is nothing but throttle angle. One that is known using throttle equation. The ECU can compute volume of the air. Additionally, if you are using throttle position sensor alone, then you need to measure the temperature. Temperature air. This air is going in, this temperature. That is called inlet air temperature. Yes, please.
This throttle angle, what you mentioned, you said that the throttle equation is used to decide the throttle angle, right?
You can do that. Yeah, tell me. Please tell me.
So now it's an actual physical sensor, no, sir?
It is a physical sensor, yes. It is attached to the throttle valve.
So that is the butterfly valve, right?
Yeah, that is butterfly. You are correct.
So, sir, how is it converted into the angle, sir? If the time permits, can you just explain maybe at the end of the class or something, sir?
Okay, fine. So the TPS sensor is nothing but a potentiometer, very simple potentiometer. Okay, so the potentiometer is you know that potentiometer generally looks something like this. It will have 3 connectors. Okay, and one stem will be coming out. Okay, and the stem is connected to one. Here you have inside, I am talking inside, there's a carbon track. There's a carbon track on which the stem is connected to one. Let me show like this. This is movable contact, and I have a carbon track, something like this. Inside the inside thread, this one TPS sensor, and this is connected to the stem. This stem. This is connected to, but this is your butterfly valve, right? So if butterfly valve is, this is connected. If butterfly valve rotates, the movable, this moves. Right? So that is nothing but, if you can say that 180 degree. This is called 0 degree, and it moves like this, or it can move both direction. The stem can move both direction. This is connected to butterfly valve. This is my butterfly valve. Okay, when driver presses throttle pedal, the butterfly valve opens. This valve opens. Correct? This valve opens. So this is the stem. You can see that. You get it very clearly shown nicely. This is the stem of the butterfly valve, under which the shaft, this is TPS sensor, that shaft is connected. So when the butterfly valve rotates 0 to 90 degree, what happens is this is called movable contact. This is nothing but carbon track. This is carbon track. Okay, so a carbon grounded powder mixed with this one, and it is coated on a non-conducting surface. So this is the background. I can move it in different color. For example, a backlight, something like that, on which this one is coated. This is the carbon track. Okay, and there are two ends. We can see that this is one end, this is the other end. Across this, I supply, say, 5 volts. I give 5 volts. Correct? These two are called as fixed ends. This is number one. This is number 2. These two are called fixed ends. That's what shown here. This is 1. This is 2. Across this, I give 5 volts or 12 volt. For understand where I say 5 volts. Okay. So now this is the movable contact. Let me give a different color so you can see it. Movable contact, the green color. This is what? This is attached to stem. When stem rotates, this will move from this position. Any position it can go. Right? So moves from 0 degree to 180 degree. When the movable contact is this position, right? I say that my now that time 0 volts appear. The movable, this one here, the center position, this is the movable contact. Here, that means it is in bottom position, 0 volts come in. If you press the throttle, it comes to new position. As it moves over the carbon track, the output will vary from 0 to 5 volts. When throttle, this is pressed, but in case of throttle, you think that it varies from 0 to 90 degree only. Right? We can think like that, it moves somewhere like this. Right? This is considered as 0 degree, this is 90 degree. Within this only it is going to move. So the output value will vary from 0. Now this value, this output is, this is the output of TPS sensor, varies from 0 to 5 volts. When throttle varies from 0 to 90 degree. So by seeing this voltage, easy you understand what is the current throttle position. This is how TPS sensor works. Amit, okay?
Yes, sir. Yes. Okay. So basically, it's derived from the voltage.
How much voltage is coming out? When throttle is ideal position, TPS the output with 0. When throttle is full position, you give 5 volts generally. So the voltage, if throttle varies by 1 degree, it may give some 10 millivolts, 50 millivolts, something will come from throttle position per degree. 5 millivolts or 10 degree, depending on resolution, what is the supply voltage given. So 2 degree means it will become, say for example, 5 millivolts. 2 degree means 10 millivolts. 3 degree means it will become 15 millivolts. So like that varies. 0 to 5 volts will come when throttle varies from 0 to 90 degrees generally.
Okay. Thank you, sir.
Okay. Now we know that this is how the air engine is controlled. Right? So the airfield ratio is controlled. So controlling airfield ratio means what you have to do, you should know how much air went in. And once you know how much air went in, equal. So this is the standard formula. For example, if I want to maintain 15 is to 1, that means my airfield ratio 15 equal to mass of the air divided by mass of the fuel, correct? And now I know mass of the air went in. By using throttle equation, correct? I can find out, this is throttle angle. I can find out volume of the air went in using throttle equation. My EC can compute. Then if I know the temperature of the air, when we said atmospheric temperature T, I can compute the mass of the air. Once mass of the air is known, then that mass of the air will be substituted here, correct? So then I need to find out fuel mass. So this is already, airfield is already 15. 15 equal to, for example, mass of the air went in equal to 10. Now I have to conduct mass of fuel. So I say mass of fuel equal to 10 divided by 15. Correct? This is 10 milligrams. I say 10 milligrams. So this will be 10 by 15 milligram fuel should be injected. Correct? Once that is computed, accordingly, the fuel pulse will be open. I told you, for example, your fuel injector, if I open 1 millisecond, if injects 1 milligram, correct? So now we know 10 divided by 15, we know that it is going to be 100, something around 0.6 milligram, 6 something, correct? Exactly, you can find out. So 0.65 milligram. So that means my fuel injector will be open for 0.6 milliseconds, 65 milliseconds. So automatically 0.65 milligram of fuel will be injected to maintain the 15 is an airfield ratio. When the amount of air went in inside is equal to 10 milligram. That is computed using throttle equation. And how this? Any doubt? So another thing also is the spark timing. In petrol engine, the torque is proportional to AFR and the spark timing. Generally, we measure in degrees. Before TD, so many degrees. These two parameters vary, automatically the torque is varied. That's how it works.
Sir, theta pi x is spark timing, right?
Which one?
The theta, what you mentioned in the previous slide. Spark timing. Engine torque is proportional to AFR.
AFR, okay. And the spark timing. I say spark timing, SP.
Okay, theta SP. Okay.
Yeah, theta spark time when you are doing before TDC during the compression stroke. Okay. Now you know that if you give spark early, what happens? Any idea? Because many of you have done a course, IC, you will be knowing. Why you have to give spark at particular time only, at particular angle, spark angle before TDC? See, I will tell you, correct? So now this is the dots are show that fuel air mixture, fuel plus air. Okay. Now it is getting compressed. Now during compression, so piston is going up from 100 cc because this is 100 cc. Now it is going to get reduced to 10 cc. Compression 10 is to 1, for example, correct? So the piston is moving up. Once it this one, at the if you give a spark after piston reaches TDC, correct? This is TDC position. If they reach, if they give a spark, then the fuel will start burning. Correct? Temperature increases, pressure increases, a downward force. The downward force, depending on pressure, downward force is created. That is converted into rotary motion or torque. Downward force is converted to torque by the crank mechanism, which is connected to gearbox and goes to wheel. Correct? This wheel is rotating. Okay. Now that compression is ended, the piston come to TDC position. Now it has come to TDC position. Now if you give a spark, fuel will burn. Correct? But we know that crank is still rotating, continuously rotating. So piston will start coming down. Because reach TDC, it is not going to remain there. Because the crank is rotating, still rotating. So the piston will start moving downward motion. Now, if fuel burns, high pressure is created. Already piston is moving downward position. Correct? Downward movement, the volume is expanding. Even the pressure increases, all the pressure is not converted into a force. Why? The piston is already downward movement. As a standard rule, thumb rule, it is thumb standard rule. It is mentioned that when piston comes to TDC during the compression stroke, when reaches the TDC at the end of the compression stroke, at least 40 to 50% of fuel should be burned. Then only the maximum pressure is created. P max is created in engine. Correct? You know that in the engine, P theta diagram, piston versus the crank angle. We know that it is shown something like this. This is 0 degree. This is 180 degree. This is 360 degree. This is 520 and this is 720. Correct? 580 and 720. So this is called as suction stroke. Suction stroke meant for 180 degree crank angle. This is the compression stroke, again 180 degree. Then this is called a power stroke, 180 degree. Then remaining 180 degrees exhaust stroke. Okay. During suction stroke, piston is coming down. And then during the compression stroke, piston is going up. Okay. Now, because you can see this is pressure. This is the theta. Crank angle 0 to 720 degree. Okay. This is the pressure inside the combustion chamber. Initially less than this one. So air is sucked in. This is 0. Vacuum is created. We never go to 0. The 0.5, 0.6 bar pressure is created inside the combustion chamber vacuum. So correct. So the air comes in. Okay. So that is doing suction stroke. Compression, when you compress, somewhere before TDC, you have to give the spark here. This is TDC. TDC is taken as 0 degree. If I give spark here, I say spark time is, say for example, 10 degree before TDC. I can give spark here, I can give different location. I can give here, this one. I told you, when you have to give spark should be given such that when piston comes to this position, TDC, end of the compression stroke, correct? 40, then only the peak pressure is created in combustion chamber. So when more pressure is created, more downward force, more torque. Correct? What is the idea? You want to have the maximum torque generated by engine. That means you have to give the spark something before the piston reaches TDC. Correct? So that depends upon how long the piston takes from this location to TDC. That is travel duration, piston travel duration. Correct? Piston travel duration depends upon the engine speed, N. If engine increases, the travel time reduces, which is called stroke time. Correct? If it is moving faster, you have to give spark in much advance. Then only, if engine is running at, for example, 1500 RPM, correct? In that case, if spark time in theta, spark time is 10 degree before, for example, 10 degree before, if engine goes to 3000, double the speed, you may have to give something around 20 degree or 18 degree. Why? The amount of time available for the piston to move from this location less. But the fuel air mixture to burn 50% of fuel, the total fuel and air mixture, it takes a constant combustion duration, right? That duration is fixed. So that means if engine is running faster, you need to give spark in much advance, so that by the time piston reaches, the time available for burning 50% of fuel is always available. If engine goes to 6,000 rpm, sorry, you have to give something around 35° or 40° much advance, because engine piston is moving very fast. So to travel this distance, it takes very less time. So that's why you have to give spark in much advance. So this is how the engine works. Spark timing, when engine speed increases, the spark should be advanced much. Similarly, the engine is not going to run at constant speed. When you want to engineer, say when you are driving a 60 kilometer, engine may be running at 5,000 rpm. If you are running at 30 kilometer, it will be less. That's how it adjusts. Okay.
Sir, sorry to stop you, sir.
No, next class. I know the next class. I saw the time. Okay.
Yes, sir.
So this is how the SI engine control system. This is another example for mechatronic system. Okay. Next class. Now that we saw many examples, petrol engine control, washing machine, camera, right, and also the robot. These are mechatronic example. Next, we will see more detailed this one. What are other parts of this one next class? See you tomorrow by 5 o'clock. Thank you.
Thank you. Thank you, sir. Thank you.
Okay.
Thank you, sir.
Okay.
Thank you, sir.
Okay. Take care.